Hello and welcome to week 12 in applied programming in Python. This week is going to be a little bit of a shorter week, but we are continuing to tackle some bonus material section that goes beyond the textbook. And this week we are focusing on a tool that is going to be particularly useful, I think, for engineering majors, for math majors, for computer science majors who are interested in going on and taking some of our artificial intelligence courses, including the new machine learning course that we are just in the process of adding. Um, Numpy is a Python package that is going to provide high performance mathematical functions. It's going to allow us to do things like multi-dimensional array multiplications and manipulations. It's going to allow us to do scientific computation, and it will allow us to do this very, very quickly. I am looking at the Numpy website right now. You should see that on your screen, and you'll notice that one of the highlights that it mentions is that NumPy is performant. And what that means is that the core of NumPy is actually not written in Python. It's written in really well optimized C code. So you may recall from the start of the course, we discussed the difference between interpreted languages and compiled languages. Interpreted languages, the system reads the code on the fly, interprets it into machine code, and then executes it. Versus compiled languages, they are converted from the human readable code to machine code before the program ever runs. And that allows compiled code to run more quickly and to be more efficient because it doesn't have to do the work of interpretation while the code is running. So Python is a interpreted language, and one of the downsides for that is that code in Python will not generally run as quickly as code in, say, C or C++ or other compiled languages. However, NumPy as a package, the core is actually written in the C programming language. We can incorporate the package and use it in Python, and use all of the Python data structures and approach to coding that makes for very convenient coding and manipulation of data. But then under the hood, anytime we're doing any kind of heavy math or scientific calculations, that code is going to be running in C, in compiled C, so that it will run very, very quickly. So we get really the ease and flexibility of Python combined with the speed of compiled C code. And this 1-2 combination is really what has made Python the go-to language for data science, for machine learning, for any kind of scientific computing. All right, this week we are going to be giving you an introduction to NumPy. My goal is not to make you experts in NumPy, but more really just to get your toes wet, dip your toes into the pool, so to speak, and get a little bit of knowledge and experience. There will not be a homework assignment this week. We will pick back up with homework next week as we add an additional package called pandas to our repertoire. And when we use NumPy and pandas together, we're going to find that we can very easily and very quickly manipulate huge data sets and perform complex mathematical operations on them. And so we'll pick back up with an assignment next week, but this week I encourage you simply to watch all of the videos and read through the material. I'm going to give you, in addition to a video or two covering NumPy, I'm going to give you some links to some reading on the web and some tutorials that I want you to take a look at. to familiarize yourself with how NumPy works so that you'll be ready for the assignments next week. Thank you.